Hello. Today's topic is increasing selectivity during complexometric titration. How to increase selectivity during complexometric titrations. And one of the methods to increase selectivity. That is, selectivity means if there are more than one uh, metal ions present or some metal ions present as impurities, how to determine the concentrations of different metal ions in a mixture separately. And that method is the increasing selectivity during complexometric titrations. And one of the methods is masking and using the masking and demasking agents during complexometric titrations. Masking and demasking agents are generally used when analyte solution contains two or more than two metal ions. Consider a solution which contains three metal ions. Suppose it is A, B, C. By direct titration, we can get with EDTA. In complex symmetric titration, generally we use EDTA, and with EDTA, we can determine the concentrations of the three metal ions together. But if we are using masking agent, masking agents, which mask both, which mask B and C get, and these B and C get masked by masking agents, and the masking agents form a complex with the metal ions A plus B plus C. With the masking agents, the metal ions B and C get masked. And only A is left free, which react with EDTA to form a EDTA metal complex, and the other two metal ions remain masked. And after that, we are using demasking agents, to demask B and C. And if we are using a demasking agent for B, then B get demasked, and we can determine the concentration of B with the titration with the EDTA. Then from the concentrations of, by knowing the total concentration of the three metal ions and the concentration of A and concentration of B, we can determine the concentration of C. And that is, or otherwise we can use demasking agent for C and determine the concentration of C. Masking agents are reagents that forms a complex with some components of the analyte and protect them from reaction with the EDTA. Masking agents are mainly used when the analyte solution contains two or more metal ions. And the demasking agents are agents which are used to free the metal ion region that releases the metal ions from masking agents. They break the complex between metal ion and the masking agents. Then the masking agents can be used either by precipitation or by complexation. The precipitation agents may be sulfide, sulfate. For example, sulfide, lead, copper, which can be masked by precipitation with the sulfide. And lead, barium can be masked by precipitation with the sulfate. Or calcium lead can be masked by precipitation with oxalate, and fluoride can be calcium, magnesium, and lead can be masked by converting them into fluorides. And the copper can be masked by thioglycerol. Then the masking can be done also with complexation. For example, iron can be masked by complexation with ascorbic acid. Mercury, copper, calcium, magnesium, lead, and tin can be masked by dimercaprol. And mercury can be masked by potassium iodide. Silver, copper, and mercury can be masked by potassium cyanide. Aluminium ion can be masked by ammonium fluoride, and tetraethanolamine can be used to mask aluminium. Then demasking agents. Let us discuss this topic by taking an example of a mixture containing calcium, cadmium, and copper. Masking agent potassium iodide is used to mask cadmium and copper. At the same time, only calcium will be free, which does not complex with cyanide, and we get calcium EDTA complex when titrated with EDTA, and copper and cadmium get masked. Then the demasking agent, we are used dichloral hydride or formaldehyde, calcium EDTA, cadmium EDTA, copper get masked. Using this demasking agent, only cadmium get demasked and copper again masked. Now, from the concentrations of total concentration of calcium, cadmium plus copper, and from the concentration of cadmium and calcium, we can determine the concentration of copper. Methods of increasing selectivity is done by masking agents. Example for masking agents: potassium cyanide, potassium cyanide used as masking agent for silver, copper, cadmium, and cobalt. Tetraethanolamine, the structure is given here, and it is used as a masking agent for iron, aluminium, and tin. Fluoride, which can be used as a masking agent for iron and aluminium, which will give hexafluoro complex like this. And the iodide, potassium iodide, can be used as a masking agent for mercury. So it is possible to determine cations such as calcium, magnesium, lead, and manganese in presence of other metals with excess potassium or sodium cyanide. Sometimes the metal may be transformed into different oxidation state. The copper too may be reduced in acid solution. Copper reduced in acid solution by hydroxylamine or ascorbic acid after rendering ammoniacal nickel or cobalt can be titrated using for example, muroxide as indicator, without interference from copper, which is now present as Cu1. And then iron 3 can be similarly masked by cyanide reduction with ascorbic acid. A demasking agent is the process in which the masking substance reverses back to its ability to take part in the reaction. Are reagents which regain ability of masked ion to enter the reaction with the indicator and EDT. Example, masking by cyanide can be removed by a mixture of formaldehyde and acetic acid. On addition of demasking agent to zinc, ZnCN4 2 plus zinc is liberated and titrated. Zinc ZnCN4 2 minus, which is less stable and which react with formaldehyde and acetic acid, and we get the zinc ions free. The other methods to increase selectivity is pH control. This method is based on the difference in stability of the complexes formed between the metal ions and chelating agents. The formation of metal chelate is depend on pH of the reaction medium. In a weakly acidic solution, the chelates of many metals such as alkaline earth metals are completely dissociated, whereas chelates of bismuth, Fe3 plus or chromium are readily formed at this pH. So in acidic solution, bismuth can be effectively titrated with a chelating agent in presence of alkaline earth metals. A mixture of bismuth and lead ions can be successfully titrated by first titrating this bismuth at pH 2 with the silane orange as indicator, and then bismuth pH 2 with cyanol orange as indicator, and then adding hexamine to rise pH to 5 and titrating for lead. Thus, we can determine bismuth, bismuth and lead in a mixture. By changing the pH. Another method is classical method used for this selectivity, increasing selectivity among in complexometric titration. These are attempted only be applied if they are not tedious. Further, only those precipitates may be used for separations which are in which after being redissolved, the cations can be determined complexometrically. For example, calcium oxalate, nickel dimethyl glycosamate, copper thiocyanate. All these can be used for this method of forming precipitates. The next method is solvent extraction. Uh, this method, in this method, metal ion in the mixture can be converted into a complex that can be extracted by a suitable solvent and determine the other metal ion by EDTA. For example, zinc can be separated from copper and lead by adding excess of ammonium thiocyanate solution. Zinc can be separated by adding copper and lead and extracting the resulting zinc thiocyanate with 4-methyl penta-2-on. The extract is diluted with water and the zinc content is determined with the EDTA titration. And another method for the increasing selectivity is kinetic masking. Here, this is a special case in which complexation of metal ion is too slow to be effective. In other words, the metal ion does not form a complex due to its kinetic inertness. For example, the reaction of chromium-3 with EDTA is quite slow. It is therefore possible to titrate other metal ions which react rapidly without interference from chromium-3. Determination of iron-3 and chromium-3 in a mixture is a typical example for such type of kinetic masking. For a general case in which the determination of 3 metal ions, as an example, at a time by masking and demasking. One example, that is zinc, copper, and solution containing zinc, copper, magnesium, which is mixed with excess EDTA, and we are doing the back titration method. Using the back titration method, we determine the concentration of zinc, copper, and magnesium together, and then KCN is added then to this solution, then zinc and to this mixture. Not after titration, before titration, another sample is taken, and to that potassium cyanide is added. Here zinc and copper masked as cyanide, and the magnesium is determined using EDTA titration. And then the formaldehyde is added. Now the zinc will get free, which is a demasking agent for zinc, and it is titrated against EDTA to determine copper, determine zinc. And then amount of copper is equal to amount of magnesium minus amount of zinc. Thus, we can determine the amount of copper in the solution. That's all about masking and demasking agents. Thank you.